And on this edition of TI Now's 5G series, we'll talk about how operators are struggling to cope with the rapidly growing traffic in their networks and how complex or not so complex heterogeneous networks can now tackle urban congestion through analysis, forecasting, and a capacity expansion plan for both radio and backhaul. Here to give us a better idea of the complexity or lack thereof in the HetNets space is Frank Royal. He's founding partner at Zona Partners. And Frank, welcome to the segment.
Thank you, Abe, and thanks for the opportunity to speak with you.
Well, thanks for being with us. So we're about to witness the release of millimeter wave spectrum for 5G technologies, that to be announced by the Federal Communications Commission on July 14th, so right around the corner. As you know, building efficient HetNets in complex cityscapes requires radio spectrum to be shared and also reused. Can you give us an example of how operators may experience this complexity in the near future?
Yes, so I think I'd like to put some context to this issue here. I mean, spectrum is, first of all, very, very important. And as we are moving towards 5G and the requirements for higher capacity, we're going to need to have wider bandwidth. And that's, I think, the premise of the FCC, wanting to basically look into the spectrum issue and release new spectrum for 5G technologies. Now, there are complexities that come with this, and there are complexities that actually on both sides. If we look at the lower end of the spectrum, it's very good spectrum for coverage, but on the other hand, wide coverage can lead to interference, which leads to lower capacity. On the other hand, the higher spectrum means wider bandwidth, means shorter distances for coverage, but it also means a lot of capacity. So when the operators go to deploy these kind of systems, there's going to be multiple types of technologies. They're going to be, the complexity is going to be different because different frequencies propagate in different ways. The planning, the design, all these items are going to be very different for the lower frequency bands and the higher frequency bands. And in a 5G network, it's going to be a network that will implement and will include different type of spectrum bands and different types of technologies. So where the operator is actually going to see the complexity is in managing different technologies, and it's also in building out different types of networks because today's networks are mainly based on macro cells. These are large cells with relatively wide coverage area. Now, when you go into, even now for 4G, we've been discussing HetNets for a while, right? But we haven't really seen much of that deployed. And a large part of that is because of these same complexities that the operators will face when deploying 5G technologies. So I think it will center a lot on the business case. It will center a lot on the deployment issues, on the management and the optimization of these networks. Just a brief comment, because you mentioned shared spectrum and reusing spectrum. So there is a new band in the United States, a CBRS 3.5 gigahertz band, which is meant for small cells. That's shared spectrum between incumbent government users and other entities, commercial entities like network operators and ISPs, wireless ISPs. So we're going to see more of that, and that again has a completely different regime, right, in terms of licensing and in terms of operation that the operators will have to deal with if they choose to go into that band. And the other item that I would like to mention is the rise of the unlicensed band. So for example, now we have LTE in the unlicensed band, as in multifier. That will also provide the operators another way to improve network capacity if they choose to go down that path of deploying LTE in the unlicensed band. So there are multiple issues here at play, and that's what's really leading to some of the complexity that they will face.
Frank, to give us an overview of how heterogeneous networks will play a big role as we reach data usage or high capacity data usage, and really why macro networks can no longer support this usage. Can you provide us with some insight of how such things as maybe lower powered base stations and technologies like GSM, LTE, and Wi-Fi will make up the HetNet?
Yeah. So, Abe, I think one thing I would like to say is where we are today. I mean, today with LTE, the raw capacity that we get is all coming from carrier aggregation, basically coming from more spectrum, coming from more frequency bands. If we look at the other features that the technology include, such as MIMO, such as higher modulation, which now in LTE Advanced Pro or release 12 and 13. So I think that's release 12. Yeah, release 12 and 13. They will implement 256 QAM, which is a step up from 64 QAM to give more capacity. We're looking at coordinated multipoint or other such technologies. But the important thing to realize is that all these technologies don't give like pure raw capacity increase. They're statistical in terms of their benefit. So they work in certain areas, whereas in other areas they don't work, or they work in certain conditions and other conditions they don't work. The raw capacity that you get is all coming from spectrum. That's why to reach the high capacity or the high bandwidth and the high download rates, we need to implement smaller cells because we need to reuse the spectrum that we have more often. That brings with it challenges in terms of interference management, and that's one item. And the other item is that as capacity requirements or traffic demand requirements increase, now we need to even move up the spectrum and open new spectrum bands. And I think what we will have in the future is that operators will have a multi-technology networks. I don't personally believe that 2G or 3G will be a part of that in the very long term because these networks are less efficient and operators will try to phase them out. They will keep some frequencies operating on 2G or 3G. We already have seen that in Europe, they would like to shut down the 3G networks and keep 2G to support legacy subscribers, whereas in the United States, different operators are taking different paths, some of them keeping 3G, some of them shutting it down in favor of keeping 2G. But in any case, Wi-Fi will be a big part of that network and also LTE and its evolution. So a big part of the challenge in terms of 5G is going to be how do we manage a network of networks, right? And there you have different concepts introduced into 5G related to network slicing or virtualization, where we're going to be able to support different networks and different use cases using that same 5G network.
Frank, and you really alluded to this in just your answer, but do HetNets for the network of the future really need to be so complex? Isn't it more of a matter of planning for the area of maximum data usage, also deploying for small cells and backhaul, and then managing through multi-layer optimization and other forms of automation? Or is that really where the complexities lie?
Yeah, so I think if we look at the word complexity, I'd like to separate it into two aspects. One, there is the operational and the deployment complexity. And as we move to a HetNet world, there are complexities related to that. So, and I think some of these can be solved through a business model. But to solve it through a business model, there has to be the technology context and the spectrum context around it to support it. So for example, if we're going to deploy HetNets in CBRS band in 3.5 gigahertz, then there's a certain business model and business case that goes with that. Whereas if we're going to deploy in the license bands that today operators use in their macro cells, that's a different story and a different context, and there are different operational complexity. If the operators, for example, decide to operate more in the unlicensed bands and give users the ability to deploy their own small cells, then there's one set of complexity related to that, and that's different from operator or carrier deployed small cells. So even in a HetNet world, when we look at complexity, if we start breaking it down, then there are different aspects. But if we just keep it more towards the operational aspect and the technology aspect, we try to make the complexity on the operational side as low as possible by increasing the complexity on the technology side. So for example, in order to manage these small cells or the HetNets better, we have introduced SON. SON is actually a complex system. It's not a simple system, but that's meant to reduce the complexity on the management and on the operation. So in terms of when it comes to complexity, I think the key issues related to small cells in terms of backhaul, in terms of management, a lot of these are actually related to business case, not necessarily related just to technology, related to deployment issues. So for example, it's hard to get backhaul into many areas because fiber, which has been heavily used by operators for backhaul, is hard to reach every single spot. So now we need to have different types of backhaul solutions. Wireless backhaul is not necessarily the answer in all the cases because, again, it's a business case issue and backhaul becomes very expensive. So we have to address these complexities on multiple tracks. One is more from a regulatory track, and the other track is from a technology track. For example, on the regulatory side, the shared spectrum, the ability to move HetNets, to deploy them in unlicensed bands or shared spectrum bands, to move them away from the operator existing frequencies and spectrum, that can allow different business models, and that can reduce complexity on one side, even though it may introduce complexities in some other aspects which may be easier to solve. So that's what I guess I would have to say about that. It's not simple, but it doesn't have to be very complex if we have the right context and framework around it.
Frank, before we go, what other pain points in the HetNet space do you think we as an industry should really be looking forward to address?
Yeah, so I think when we talk about HetNets, we have to look at the deployment scenario and then we talk about the pain points. So if we look at carrier deployed small cells, I think the major obstacle has been locating these things, finding where they should be placed, and more importantly, I think getting the right zoning permits and facilitating the process, shortening it, and making it low cost. And also, for example, in terms of operational expenses, the capex, the amount that operators have to pay for pole lease space or leasing building sidewall, these are key issues and key parameters that have to be addressed because it's ultimately a business case issue. So I would say the cost related to the process, the zoning, and the permitting. And the other side, I would say, backhaul, which has been a very big issue related to small cells for a very long time. So that's on the side of the carrier-deployed small cells. On the side of the self-deployed small cells, such as Wi-Fi, such as multifier, I think here we have a different set of issues that are more related to the cost and are related more to the business model and the way that the operators work. For example, whether they want to keep, whether they want to maintain SLAs, and how they view the use of shared spectrum and unlicensed spectrum in relationship to their quality, to the quality of their service. I think these are the issues to be handled on the other side, which are the self-deployed small cells. So there are different issues here, and I think we've kind of come a long way to addressing some of these issues, but we still have a little bit more to go.
Frank, it was good to talk to you. It might be also good to talk to you later in the summer, really after the release of these millimeter wave spectrum bands over the 24 gigahertz. So we'll try to catch up with you before the fall.
Thank you, Abe. It's been a pleasure, and thank you, and thanks to the TIA Now team for this opportunity.
Frank, thank you very much, and thank you for watching this edition of TIA Now's 5G series. For more segments on 5G and other topics such as NFV and also IoT, please go to tinow.org. So long.